Now let me say something about what to expect in the later part of this course, because in November the nature of this course is going to change quite substantially. So in the later part, in the later weeks of this course, what we're going to be concerned with, for the most part, will be this project, this TinyJ project. Now this project, 180, okay, requires students to complete an implementation of a small programming language called TinyJ. Here the J stands for Java, and tiny means it's a tiny subset of Java. So every TinyJ program is also a Java program. And so if I give you a TinyJ program, everybody in this lecture should be able to execute it, right? Because you should know how to compile a Java program and how to execute bytecodes that are generated by a Java compiler. So if I give you a TinyJ program right now, nobody should have difficulty in executing that program. You just compile it using a Java compiler and then execute the bytecodes on a Java virtual machine. However, after you finish this project, you will have another way to execute TinyJ programs, because this project requires you to complete your own implementation of TinyJ. What you will actually be asked to do is to complete a compiler for TinyJ that will compile TinyJ source programs into TinyJ virtual machine instructions. So this is sort of analogous to what a Java compiler does. So a Java compiler compiles a Java program into Java bytecodes. These are instructions for a TinyJ virtual, a Java virtual machine. Okay, and then to actually execute the TinyJ virtual machine instructions generated by the TinyJ compiler, you will need a TinyJ virtual machine, right? Just like you need a Java virtual machine to execute the Java bytecodes generated by a Java compiler. The TinyJ virtual machine is analogous to a Java virtual machine, but much, much simpler. Basically, the J virtual machine can be thought of as the simplest virtual machine that I was able to design that would be able to execute TinyJ programs without much difficulty. And it's designed for simplicity rather than efficiency. So whenever there was a choice between having a machine be able to execute programs more efficiently, but at the cost of making the machine more complicated, I didn't make that choice. So always the choice was to make the machine as simple as possible. And also TinyJ is a much simpler language than Java, so the machine is simple for that reason as well. All right, so you have to complete the compiler, and then you have to complete this simple virtual machine. So that's a separate part of this same project. This is a three-part project, actually. The first part asks you to complete a syntax checker for TinyJ. The second part asks you to complete a compiler for TinyJ. And the third part asks you to complete a TinyJ virtual machine that will execute TinyJ virtual machine instructions generated by the compiler that you completed for the second part of the project. And then when you've completed all three parts of the project, then you will have this second way to execute TinyJ programs. So then you will just run your program, and it will translate the TinyJ program into TinyJ virtual machine instructions, and then execute those TinyJ virtual machine instructions using your TinyJ virtual machine. Now, this is a major programming project. It will consist of three parts, and it will involve reading and understanding code that is already written, as well as writing your own code. So it's sort of like you joined, you're a junior programmer and you just joined a team where somebody else was working on this project, but they left, they were reassigned to some other team, or they just left the company altogether, and then you were asked to take over the project and to finish it off. So you have to fill in all the gaps. So there are lots of things that haven't yet been done, and that's what you have to do. You have to fill in the gaps, and so you have to read and understand the code that has already been written, and so there'll be a substantial amount of that, and then you have to write new code. All right, so that's actually so junior programmers often spend a lot of time reading and understanding existing code, much more than they spend writing their own code. But anyway, this is what you have to do, and the project has to be done in Java, which you are expected to know. I'm not going to teach Java. There seems to be some lag here because there's about 5 seconds. 90% thinking. Well, maybe 90% thinking and reading and reading and understanding existing code. And that may be accurate. Though it really depends on how fluent you are in Java. So I have had students. So you're supposed to know Java already because you're supposed to have taken 2.11 and 3.13. Now, I sometimes have students who say to me, I learned Java some years ago and I haven't done Java programming for quite some time, and I've forgotten quite a lot of the Java I used to know. So if you are such a student, you have until early November to refresh your memory of Java. So if you think that you can't do the programming assignments from the most advanced Java course that you took earlier anymore because you've forgotten so much Java, then what you need to do is between now and early November, just refresh your memory so you're back at the state that you were shortly after you finished the most recent Java course you took. So the fact that you're in this course should imply that your knowledge of Java is comparable to so either you took 3.13 or your knowledge of Java is comparable to Queen's College students who've taken 3.13. Okay, so but if you've forgotten a lot of the Java you once knew, you have until early November to refresh your memory. So well, what I'm saying is if they let you into this course because so the department has prerequisite rules, and so you must have satisfied the department that your knowledge of Java is equivalent to the knowledge of somebody who's completed. You started your higher skill code. Well, then you you're supposed to know. So you must your knowledge if you've done higher skill coding. So you took 3.13 in C++. Is that? Do you do that at Queen's College? So they're teaching 3.13 in C++ now, but then you must have taken 2.12, right? Did you take 2.12? Okay, so 2.12 is definitely in Java, right? So 2.12 has to be in Java. All right. So all right. So basically, the only people that I've had who have had trouble with the Java programming was the people who had forgotten a lot of the Java that they learned in 2.12, or who got a maybe barely past 2.12. So you got at least a B and maybe B plus. So students who got a reasonably good grade in 2.12. I don't remember any such students having difficulty with this project because they didn't know Java well enough, except for some students who took the course many years ago. But for those students, I'm saying you have until early November. Okay. So as long as if you completed, if you didn't have trouble passing 2.12, you got at least a B plus, and you remember the stuff you learned in 2.12. My guess is you'll be okay because I've been teaching this course for many years, and it is that those students, when they have difficulty with the project, it's not because of their knowledge of Java. Okay. do remember that although you won't be asked to write any significant amount of Java code before early November, I might give some examples of Java code. In fact, I will. So I'll be using Java in some examples, but you won't be expected to write substantial amounts of Java code before early November. But once we start on this project, you will have to write Java code, right? So don't think that you can get away with not knowing Java, because that is not the case. All right. So the purpose of this project is not to teach you how to program. You're supposed to know how to do that already, but rather to provide a basis for concrete discussions of many aspects of programming languages. And I've listed some of the more important topics here. You're not expected to understand these topics right now, but at the end of the semester, you should be able to look at this, what I've just highlighted here, and for each of these terms, you should know what it means, and you should be able to think back to a part of the course where I covered material relevant to that particular topic. Okay, so if at the end of the semester you don't know what heap dynamic memory allocation is, then that means you missed something that was important. All right, well, so sometimes students email me and say, well, can you explain what is meant by heap dynamic allocation? And my usual response is just to refer them to the slides for that topic, or to the recording of the lecture where I talked about that. But in some cases, students have to make appointments to see me so I can help them some more. But certainly, if at the end of the semester you find that some of this highlighted stuff doesn't make sense to you, then that means there's something you missed. Okay. The first part of the course, however, will be quite different. We're going to spend a lot of time on functional programming, which is very different in nature from the procedural and object-oriented imperative programming that you've been doing in C++ and Java. Perhaps the most significant difference is that in functional programming, variables and data structures are immutable. So once a variable has been given a value, its value will never change for as long as the variable exists. And once you've created a data structure, its contents will never change for as long as that data structure exists. So a data structure in functional programming is sort of like a hard copy book, a printed book. So once you've bought the book, the contents of that book will not change. In imperative programming, the data structures are sort of more like online documents. So what the document contains today may not be exactly the same as what it contains tomorrow. Right, and a very important part of imperative programming is the ability to change the contents of data structures, to update the contents of data structures. You're used to doing this, for example, when you call a modifier method of an object, then you're doing it to update one of the fields of the object. And this is something you can't do in functional programming. Right, the objects are immutable. So functional programming has an entirely different field to procedural and object-oriented imperative programming. And one of the objectives of this course, a very important objective, is to introduce you to functional programming. We're not going to do any really advanced functional programming, but you'll be introduced to functional programming. The language we will use for this purpose is going to be Lisp. There are many languages that could be used, but Lisp is a good language to use for functional programming. It's one good language. Now, we won't be talking about Lisp for a little tonight, and it's not in detail, and probably not on Monday either. We may not get to Lisp until Wednesday, but if you wanted to learn a little about Lisp before next Wednesday, you could read this page, right? That this page is linked from this. If you just click on this Lisp link, all right, then it'll take you to this page. So this is an easy page to read. You don't have to memorize this stuff. This is just for people who are curious to learn a little more about Lisp. And Lisp is a very old language. It's the second oldest programming language, high-level programming language. The oldest is Fortran, which is only about a year older. and a lot of the documents that you can find online about this were therefore quite old because the language itself is so old. But anyway, this is one of the newer pages about Lisp that I've seen, and it's quite an easy read, and you're not required to read this, and you're not required to memorize this. In fact, let me just warn you that in this course, we are going to be using Lisp for functional programming. All right, so I'm going to be teaching functional programming, or giving an introduction to functional programming, and we're going to use Lisp as our language for functional programming. So that means that we're only going to be, we're not really going to spend any significant amount of time talking about aspects of Lisp that are not used in functional programming. And what's more, if you use features of Lisp that are not consistent with functional programming, you will lose points on exam questions. Well, unless the question explicitly says you can use things that are not functional. But if it doesn't say so, then you have to program in a functional programming style. And if you write code that's not functional in style, then that will not be correct. And similarly for the 4-credit programming assignments. Now, I'm mentioning this because I said it's a good, this page is a good page to read if you should sort of learn a little bit about this before next Wednesday, when we'll start covering this in more detail. But some of the code on here is not functional. All right. So for example, you can't use keyprint because that's I/O, and functional programming there's no I/O. And another thing you can't use is setf. So if you use setf in answer to certain exam questions, you're going to lose points. You may even get 0. Right, because that's not consistent with functional programming. So I just want to get this on record right now. I don't want people to say, you know, when they get 0 in answer to an exam question. On this page, which you referred to on the first day of classes, they were using setf. So why can't I use setf? So I want to. So this page is about Lisp, whereas in this course you're only going to be using Lisp for functional programming. So it's very important to be aware of the fact that you can't use features on many exam questions. In fact, on most exam questions where you ask to write Lisp, you will not be allowed to use features of Lisp that are inconsistent with functional programming. So I just want to mention that right at the outset, especially as I refer you to this page. I think I'd better take attendance, actually. In fact, this is quite a large class, so let's quickly get through this. All right, so I'm going to call out your name, when I call out your name, just post present like this, right? That should save some time like this. So just post present. Now, this page tells you your Euclid username. And one thing you have to do after the end of the class period is actually set up your Euclid account. So your Euclid account is, if you look at page 6 of this document, it's described here. So you will need your Euclid username to set up your Euclid account. So tonight, before next Monday, set up your Euclid account, and you will need your Euclid username to do that. And your Euclid username is actually shown here. So make a note of your Euclid username when I call your name out. George Aguilar. Thank you. Jahed Ahmed. Jahed? Yes, thank you. Michael Alberto. Michael, thank you. Rafat Ali. Rafat Ali. Rafat Ali, absent. Okay. What's going on here? Rafat Ali, are you here? Are you the same? Are you this person? This is not English. Or you're on Rafat Hack? I think you're a different person. So Rafat Ali is not here. Okay, so absent. Okay, William Almont Cabrera. Thank you. Jeffrey Amonkwa. Jeffrey Amonkwa. Thank you. Eric Arellano. Eric Arellano. Thank you. Emmanuel Barasevich. Thank you. Jonathan Carley. Okay. Ming Chan. Thank you. Michael Chang. Thank you. Feng Sheng Chen. Thank you. Jun Yan Chen. Zhen Chen. Zhen Chen, not here. Wenzu Chen. Wenzu Chen. Thank you. Yao Hui Chen. Oh, Zhen Chen, you are here. Can you post present, please? Can you post present? Zhen Chen? Thank you. Okay, Tanya Chowdhury. Can you post present? Dina, first, before I get to, after I call their name, there is, you do have to read the slides, the to-do slides, okay? So if you leave, before I get through this, be sure to read these to-do slides and do these things before August the 31st, okay? So, so you just look at those, and in fact, let me just show you all the slides. So there are all these things that you have to do. But let me go back to taking attendance. So because I noticed some people were leaving. Zihan Huang, okay, so he's here. And Nisat Islam. Nisat Islam. Absent? Okay. Hassan Jahan. Hassan Jahan. Absent? Oh, you're here. Asakala. Zinglin. Oh, you are here. Thank you. Sakib Mahmood. Absent? Okay. And Yas. Thank you. Mohammed Nureen. Thank you. Yinghai Wong. Yinghai Wong. Yeah. Darren Zhang. Darren Zhang. Darren Zhang. Absent. Xingyu Zhang. Was taking attendance. I finished taking attendance. And so here are things that you should do before our class on Monday. So you can read through these things and just make sure you do them before Monday's class. I think you'll find that it's straightforward. Okay. Pranti data. Well, let's see. I'll make with the I just emphasize possible. So this is the last, the 8th slide. But the earlier slides would be as we can do.
Hello.
Recording on so no one has any questions right now. Would be as would contain just a part of this material instead of all of this material. Okay, so this is the to-do list. I'll make it bigger for you.